Hello, everybody, and welcome to another quarterly development update. There's been a lot going on over the last 3 or 4 or 5 months, so I'll get into kind of discussing what's been happening. Like some people have been leaving, some people have been coming on board, what's been happening with the development. But what I wanted to consume the beginning of this with is to introduce somebody that just came on board. His name is Victor Moreno, and his title goes by Distinguished Engineer at Cisco, and he's been kind of helping Nexus kind of on the sidelines for the last, at least, about 2 years, Victor, since about 2018.
About that, yeah. About two or 3 years, yeah.
Yeah, so Victor's been kind of helping and volunteering on the side, and then he was actually the person that I started discussing the Nexus protocol with. I actually called him up first. I was like, Victor, I got this crazy idea. Like, I think it'll work, like a GPS routing system. And he's like, well, a routing system's just a decision tree, and it's really just to find a direction. So he's like, I don't see why it wouldn't work. And then he did some research, and we found some papers that people had already started to write on it, right? So it's been a really enjoyable experience working with him thus far. And now that we've been in a better financial position and everything, it's been nice to be able to offer him a contract. So Victor is officially on the team now, and he's I guess we'll get into like all of the details of it, but right now he's mainly focused on helping with the documentation and architecture. I guess, Victor, would you want to give an introduction on some of your experience and kind of what got you to this point?
Yeah, so I've worked in networking for about 30 years now. And I've done all sorts. I've built data centers, large enterprise networks, collaborated in service provider backbones, a lot of internet work group participation. So I've been involved in one way or another very intimately with networking for a very long time. In that journey, I met Colin about 3 or 4 years ago, actually, and started learning a little bit about blockchain, and started seeing a little bit about the vision that he had for a satellite network, that was more of a crowdsourced endeavor and more accessible to the masses. And in having that conversation, there was also a lot of openness that I saw in Colin. And if you've ever worked in networking, things are very well established, right? It's almost like building roads. You mix the concrete and the cement in a certain way. You don't deviate from that, or else stuff will happen, right? But I think in technology, we have a lot more flexibility, and there are things that aren't being pursued. So we're looking at pursuing some of those alternate approaches, and it's not just a wild shot at things. We know what works, what doesn't work, and we know where there are reasonable chances of success in innovating. So some of what we're looking at for this satellite network, and frankly ad hoc network in general, is still in need of being architected. So that's where Colin and I have been brainstorming and working together on actually putting down on paper what exactly is it that we're going to go chase. How do the different elements interface with the existing network, with the future network? There's still a lot to discover, but that it's a very, very interesting area of exploration to me, and that's my motivation for joining. Aside from the fact that I've always been inspired by the possibility of using the Nexus network as well as the Nexus currency as an enabler of underprivileged societies, and there's a whole philanthropic aspect to this. So it's a little bit of a breaking the mold endeavor. I'm very excited about it, and I think there's going to be some very interesting things that come out of it from a technical perspective, but also from a usability perspective for the network. So so it's I couldn't think of a better thing to do right now. So excited about it. And thanks for having me on board.
Yeah, thank you for jumping on board. I mean, I'm really excited to be able to have to be able to lean on a lot of your vast experience, because I'm kind of like an ideas guy, right? Like I come up with all these things, but I don't always, since I don't have as much experience, 30 years, I think I'm like, what, 20, almost 20 years, I guess. Wow. That's damn. Okay. I guess I kind of have, but like, not in the networking stuff. I mean, my journey's kind of just been coming from higher level programming down to lower levels, right? I started programming when I was 11, making video games, right? And doing the graphics stuff. And then that kind of, when I discovered sockets, I think that was in like 2015, I was just like, oh my gosh, this is the backbone of the internet, right? And I started to really understand how it all worked. And from spending a lot of time with Dino and Victor, I learned a lot about it. I mean, some of the pitfalls, like you guys would criticize border gate protocol and, what BGP is what people call it. And, Dino always kind of said that, like, he liked that, there was a young whippersnapper coming in the IETF, because the IETF is, a lot of, I guess, older gentlemen that are very experienced and have been doing the network thing for quite a substantial amount of time. And I guess I started kind of joining the Lisp working group, and that's where me and Victor met and we started discussing. And that's where actually some of the original architecture was vetted. If you remember that one time in Montreal, Victor, with the consensus layer, adding a layer on top of the OSI, right? And discussing that as how we can manage root of trust and things such as that. And I mean, the room kind of exploded in a good way. I mean, I got a lot of questions, and I got a lot of people like, at first we're just kind of like, what are you talking about? What's this blasphemy? But then when I started really, drilling into it, everybody started to realize, oh, wait, there's actually some merit here, and that's when I started to really realize, wow, there's a lot of merit here. And then that slowly, over that experience of working together and, integrating, the locator identifier separation protocol, that kind of birthed this one stack that we're working on right now, which is, the architectural stack, which is, we have the Tritium software stack, which was like the first birthing of it, which that kind of ends up being the consensus layer and the application layer, right? So the consensus layer is ledger operation, and then application layer is API, logical and interface. So it's cool how it all kind of fit together, right? Seamlessly after that, because we were just missing the lower end and the bottom end of the stack. But what's really valuable about, working with this, locator identifier separation protocol is, as Victor said, it acts like an ad hoc network. So that's a huge issue that Elon right now is facing, is he's trying to deploy this giant, satellite internet. And I mean, they don't get routes everywhere. It's spotty and it doesn't always work. They've had a lot of issues with bandwidth issues and things like that, because to get that massive coverage and to go to that ISP model, it's very, very, very difficult to do. I mean, Cisco has been doing that for, 40, 50 years, but nobody's really deployed their own entire satellite constellation. It requires an incredible amount of, money to do. So, that's where we've kind of, combined together this blockchain knowledge, right? Where we can create incentivization systems and then combine it with a lot of, Victor's network expertise in designing the actual lower level routing system. So we're kind of starting off. We had the Nexus protocol white paper, and we're working on the one stack white paper next, which is going to be the protocol version 001. And leaning on a lot of the things that we've learned from the IETF as well, like, following the working group models, right, and having consensus-oriented standardization. And right now, the standardization is kind of just starting with me and Victor, where we have the first document, NP000, which was the one that we released on December 21st, 2020. And now we're working on NP001, which is going to be kind of like our own RFC system, right? And what we want to also do too is, from at least my personal experience of witnessing the IETF, is the internet's design goals and the design requirements, the technical implementation hasn't fully been able to meet that, right? One of the design, goals of it was to be an open network, right? And it does have that, in a very basic sense, but, because of that openness, there's all these other security, pitfalls that come with it, you have to, watch your ARP messages on your local networks, because you can get man-in-the-middle attacked on public Wi-Fi's. And, it was designed more as like a closed system that, like between trusted participants. And when they opened it up, it just, all these other multitudes of issues kind of materialized. I mean, one of which is the hardware-defined routing. And that's one thing that I remember you were really interested in, Victor, is the software-defined router aspect of it, because right now all these routers are just, they're hardware defined, and which means that you have to buy a new router if you want to change, to IP version 6, right? If your router doesn't support IP4, you have to buy a new router. It's a physical hardware that's required. But, software defined systems are starting to become more and more prevalent. And if you guys remember Vector's Galactic Sky, one of their claims to fame with that was software defined satellites, right? So we're taking that software defined nature of it and we're weaving that into this operating system and into the satellite network and into the routing system, so that essentially when there needs to be a protocol upgrade, everyone will be able to synchronize their update and just download the new software and it'll all work right out of box, right? So that was a really important, I guess, component. And it's kind of the whole thing it evolved naturally on its own, like the original concepts was just, putting Nexus on some satellites and, having a higher level of redundancy. And we always wanted to have a new type of internet model, but there was a lot of issues that we ran into, such as the frequency licensing requirement. And then, the discovery of the ISM frequencies resolved that. And then the next big one was, routing. And I remember in the IETF, what was it in Thailand, we were talking about that. Remember, we were doing the satellite orbital,
Right.
How are we going to do routing? I mean, it's just IP is not necessarily going to work. And that's where, this whole GPS system really kind of took form. And what's really cool about it too, is it affords us this new type of contract functionality where the web becomes more spatial, right? It's like an augmented reality for the routing system in a way. What I mean by that is the routing system is a geospatial routing system. So instead of saying I have this IP address and I send it, and correct me if I'm saying this technically correct, Victor, but you basically send your packet out through your router, through your NAT, which then goes to the main network, which is your ISP, which then has the range of IP addresses that it owns. And then your destination IP address, which tells you what exact port, right? Is that correct? The port off of that specific route.
Yeah.
And that tells you the port, which then takes you to the next network. And then from that network, then you narrow it down from the leading network byte down until you finally get to the final, the final address, and then you have it. But the problem with this system is that all of these IP addresses have to be uploaded into the routers, right? And that's succeeded with BGP. Is that correct, Victor? ForGate protocol.
It has succeeded. I mean, the big difference, Colin, is that those routers are fixed in place.
Yep.
So any pair of routers will have a connection between them or more than one, but that is fixed. So the topology, which is basically the combination of the links, the ports, and the routers themselves, and how they are actually laid out with relation to each other, that is fixed. So that gives BGP the opportunity to do two things. One is to propagate the updates across this fixed topology, but the other one is to summarize information in certain points where it can be aggregated because the topology lends itself to that. So I mean, BGP has achieved that on the internet, but the internet is largely static. Now, move all those boxes into space and have them start rotating, and they're on different rings. And now the relation between the boxes in one ring and the boxes in another ring is constantly changing. So now your topology has become mobile. And that's the interesting challenge there. And that's where IP is something that we're going to have to use in an upper layer, because you're going to want to have communication between ground and space, right? And you're going to want to have communications between ground stations be brokered through space.
Yep.
So you have to preserve that IP semantic for the final destinations and the sources. But as you actually transfer information over space, it makes sense to find a different construct to actually forward, because mapping an IP address to a set of ports that will get you in the right direction is not an option at that point, right? So, so what we've found is that, well, what is something that all the satellites know well? Well, they have pretty accurate clocking and GPS information. Okay, so therefore, you know where you're at, but you also know in which direction to beam some information if you want to get to a particular destination. So if instead of having a route that says to get to this IP address, send the traffic to this other router that has an IP address in turn, you say, well, to get to this particular IP address, you need to beam your traffic towards these geo coordinates. And they may not be precise because the receiving satellite will be moving, right? So then you can start beaming your traffic in that direction. So to your point about virtual reality, it's like you're looking out at space and you're saying, oh, it's roughly there. And then you're just going to beam in that direction, and then you will hit a satellite that is on path, or you will find the satellite that is on best path based on other mechanisms, right? So basically what we're doing is think of what a bird would do, right? So a bird would actually somehow using its instincts know, okay, that IP address is in that direction. So I'm going to fly in that direction. I'm not going to go around. I'm going to fly in that direction, right? Straight there. So that's the big difference between what we're doing and what's been done on the internet. So for you to do such a thing, we don't even have to transfer information about how do you actually choose an inclination to go in a particular direction, right? So if you want to get to a particular set of geocoordinates, you do that calculation yourself on the satellite. So you keep calculating and beaming, well, I need to be at so many degrees of inclination to actually get to that next satellite. So that's what you do. And what's my closest satellite in that range? Once you find that, then you go ahead and beam. So instead of having BGP transfer information across that entire network, the network itself, the only thing that needs to be transferred is what are the geocoordinates that we need to get to. And once you know that, once you say, okay, this IP address is on these geocoordinates, which you know on ground, right? The minute you connect a computer, you can determine the geocoordinates of that computer. Your phone itself can tell you which geocoordinates it's at. So we register that with the mapping system. And all we need to do is have the satellite know from that mapping system that for a particular IP packet, it needs to send the traffic to a set of geocoordinates. And then the calculations can be done locally. There's implications to that. I mean, we're oversimplifying it here. There's a lot of cases where there may be loops and there may be failures of this, but bearing that, right, the general concept to pursue is that of forwarding based on basically where you're at physically. And that's what we want to do in space. And if you think about it, you could do that with satellites, but you could do that amongst cars, bicycles, phones, right? You could do that on Earth as well. The satellite space is a little more better controlled. And then we have a say on what operating system is running there. So that's the big opportunity. But if that operating system is successful, you could actually see it being run in endpoints, in cars. And so now you have it the equivalent, but on Earth, right? Some may say a little cheaper to deploy, right? So
yeah, and one of the really desirable characteristics of this architecture that I kind of found was that it's somewhat stateless. I mean, we have mapping state that we need to manage, but we don't have to upload all these IP addresses into the routers, which, you know, the router basically
transmit them.
Yeah, you're mapping a port to a MAC address and an IP address to a MAC address through your ARP message, and then that's how everything is routed through the internet. But you need to upload all of those routes into the router. And, you know, there is authentication in the routers, but there is, you know, possibilities for people to hack routers, right? And try to redirect traffic to, you know, wherever they want to redirect it. And correct me if I'm wrong there, but that's just my basic understanding of it. And, you know, from that.
Yeah. So, you know, that's one of those scenarios where the calculation of resilient paths is a huge problem in routing. Why? Because you may end up calculating paths that just basically bring you back home. So you never left. The packet just cycled straight back to you. And the avoidance of those loops is why you have to transmit all this information, and everybody needs to have a full view of the entire network. And a view of the network from an IP perspective is basically a full-on graph of links and costs and destinations. So rather than having that graph replicated everywhere, all we're saying is, listen, you need to go east. Now, if along the way you find that your next hop to go east is failing, you could make a local decision to go east on the next guy on the ring that takes you east. It's not as optimal, but you could actually choose to do that, and you still know that you're going east. And you could have a heuristic that is very simple that says, okay, don't deviate more than so many degrees, because then you're going to start risking coming back down, right? So in general, just the fact that you are basically transferring messages between nodes that are fully aware of location at all points in time is basically that's how we're replacing the routing protocol itself and the calculation of the loop-free topologies. And you can do multipathing, you can do all of these things, but it's a very different paradigm, right? So very, very different problem, with the advantage of a very different tool, which is basically the fact that you have that current information in your GPS system, right? You know where you're at, and therefore you should be able to easily calculate what your beaming angle should be to go to a particular destination. So then you put tolerance around that, and then you have a window in which you can choose one or more satellites to be your next hop.
And you protect against looping without having to actually use BGP to know the map topology in the state, because you know where you're at. And so you can tell if you're looping, because we're holding some of the state and the actual physical dimensions by extracting that with the GPS coordinates. So we know what direction we need to go, and we know where we are. And then the other really beneficial aspect of this too is it allows us to add geospatial contracts, right? You can deposit Nexus into this geospatial contract, and since ground stations will know where they are and they'll bind and reference each other from each other, then you can start to access, contracts that are bound to local geographic areas. And that's where the web becomes more augmented and, interactive, where, I'm interacting with the internet in my physical coordinates, right? You could maybe access a web service that's only, regionally bound within a certain wide radius locator or anything else like that. So it affords us not only just, a really efficient routing system that works really well with dynamic systems, but it creates this whole new geospatial contract capabilities. It's kind of like a geospatial oracle in smart contracts, if you want to.
Right. Yeah. And I mean, the fact that you are including the geo coordinates as part of your routing semantics is super powerful, because you can write policy against that, right? Whether that's restrictive or all inclusive, it doesn't matter. Now you have the power to do that. If you think of the IP addressing today, you could kind of build a mapping, but it would be something very static, and it would be ephemeral, because if somebody moves a block of IP addresses out of that range, then it doesn't map to the geographic region anymore. So you can kind of correlate IP addresses to geography, but it's not an easy thing to do, and it's very, very volatile, because things will change. In this case, you're natively using the geo coordinates. So you can natively write policy to that without having to go through degrees of indirection that don't, they've happened as a consequence of what we've done versus something that was there by design, right? And in hindsight, everything is 2020. This is not meant to be a ding against those who designed the internet. I mean, frankly, the internet is a beautiful work of engineering.
We wouldn't be here without that.
Right. But if you're going to put something in space with different software and different routers in a different paradigm, you might as well evolve it, right? And we know a lot today that we didn't know back then. Right? So our knowledge of the internet has evolved a lot since I started working on it, and that makes this a fantastic opportunity to actually tap into a lot of that potential. And then the other aspect to it, which I think is fascinating, is the fact that we can now make security, connectivity inherently secure. And you've seen the mess that we have on the internet right now. Everyone wants to go work from home, but the reality is that the internet as is not prepped for that. It's not safe, right? We're basically out there in the wild open. Now, if we can start securing our communications, which we can with consensus type networking, then now we're talking about a much different game. It doesn't matter where you are as protected as if you were using a dedicated endpoint inside a dedicated network, inside a bricked facility. That has constraining as it sounds, that's what you want your working environment to be like, and then you open it up to whoever you invite, right? But it's basically a matter of how do you actually prevent the bad actors from breaching into this. So as we go into IoT and using the network more and more broadly, nothing's going to be behind a brick wall. That's not the point. The point is, can we create a digital fortress in basically using these consensus mechanisms, et cetera, and do that natively in the operating system? That the other thing that drove me to this is, well, for years we've been trying to fight getting all this functionality that inherently happens in the network, but how do we actually tie or bind the endpoints to those functions? And a lot of the times it is basically you have to use a particular network to benefit from that. But if we had basically the network stack of the endpoints be enabled with this type of functionality natively, then there you have the solution to the problem. And if you look at the network stacks of Unix endpoints or phones and all sorts of different IoT devices, very primitive, right? And we don't have to load it with everything that a router does today. We have to put the right components in it, right? And that's part of the architecture work that we're trying to get to. It's like, well, of everything we've learned, what do we need? That's point number one. And of those things that we need, what's the most useful way of actually, or the most efficient way of actually getting to that point, right? And it's surprisingly simple. There's not a lot that you need to put there. So that's been another interesting aspect of what we've been doing.
Yeah, I mean, kind of like I took, my experience of understanding, programming and games, and I took that into learning Bitcoin and understanding, what made Bitcoin work, which is another really amazing feat of engineering, right? And understanding what the aims of it were, the requirements of it, and then where some of the technical limitations ended up manifesting. That's kind of what birthed Nexus, right? This is similar, but with the internet and the IP. Is we're taking a lot of this experience that we've had collectively and learning what architectural aspects fulfilled what we were looking for, what are requirements that are still falling a little bit short, such as the safety and security, and availability issues too. And really drilling that forward into kind of the next generation of a routing protocol, right? One that we're designing and aims to be able to start connecting a lot of these people that are currently without connectivity. One of the reasons that there's only about 2 billion people connected to the internet is because it's too expensive to go lay fiber. All these third world countries, there's not enough money to be made in the ISP model. Now, Facebook tried to bridge that by raising a bunch of money and trying to give out cell phones and stuff. But still, that's based off of Sarnoff's law, right? Which is V equals N. It's a linear relationship where you put money in and you get linear profit back, right? And that's how the conventional business models work. But we're focusing this one on Metcalfs, where when you incentivize the hardware deployment, and then you make the router software defined, and then you make it all wireless as well. Using 5.8 gigahertz, we have the capability to get up to 10 gigabits per second per satellite, right? Which is a pretty significant, that's data center type bandwidths, if you have a single dedicated beam, and you don't have to lay all the fiber, right? It's just, there's so many things that, this is really shooting to bridge, that capability. And Nexus, the currency, NXS is kind of like a currency developed for an internet. I guess like Bitcoin is said to be, the internet's, currency, which it is for the classical capital I internet, right? But Nexus, the currency itself, is designed, from the bottom up all the way into the operating system and into the routing protocol to drive the economics of this new internet, this new ad hoc network, right? And one of the beautiful things about it, especially working with locator identifier separation protocol, is it'll interoperate. Well, once we get one ring up, right, that one ring's not going to have full ground coverage for everybody. You'll be able to hit the satellite whenever it's overhead, but it's going to take time for all of these satellites to be deployed. And so in that meantime, since we'll have, it basically goes signal layer, locator layer, and identifier layer, as you guys noticed, locator identifier separation protocol, right? So the one stack incorporates some of the architectural elements of Lisp so that we can have interoperability with conventional IP packets, which means If I want to send a packet to Victor and I have a satellite connection, but Victor only has, a classical ISP connection, we'll both be registered to the same mapping system, right? He'll just be registering his, IP address as the RLOC. And then I'm going to send up to the satellite. The satellite's going to get to the closest ground station, let's say, in the city that he's within. And then that ground station will act as a gateway, and then it'll strip off that outer header, right? And then re-encapsulate and put on a new header for IP4 to his specific routing locator. So you basically can have these types of gateway proxies that will allow us to interoperate between Nexus protocol and Internet protocol, so that you'll be using it as if it's the same seamless interface, right? Whether you're using the capital I Internet or whether you're using the Nexus protocol, it'll feel like you're using the same thing. And that's going to be really important to get people to really adopt it, right? And that's something that Elon's really facing significantly right now, is in order to get people using it, he has to have full coverage. But he can't get full coverage until he gets people using it to get the money to deploy all of those satellites, right? And that's the Sarnoff's law with, Metcalfe's law, like we're doing, V equals N squared, right? Which basically states that the value of a telecommunications system is proportional to the square of the participants in the system. So what this is, designed to do is accurately reflect that value and, have that value translate into further proliferation of the hardware that is independently owned by different people. And I think, the vision of the internet, I think, really was to have something more like that, to be decentralized. And the IETF model is designed to be more decentralized and working group oriented and rough consensus. But I think the engineering, though it's beautiful engineering, has taken us to a certain point where, to get to that next step, we need to look at the hardware, and how the hardware is deployed. We need to look at the gamification of the system, because from what I understand, the IETF usually has a large company that's sponsoring it. And, you have your different, your regional directors, and then you have your working group chairs, and it's somewhat hierarchical from what I understand, but still decentralized. It's like a hybrid of the two. Is that correct?
Yeah, it's a democracy, if you may, right? So these area directors are basically agreed to be the right people by consensus. It's not necessarily a position of a lot of power. It's more of a facilitating position. So in many cases, the volunteers that are doing this are doing it out of their interest for the progress of the standards bodies. So I'd say it's a pretty healthy organization. And yes, the participants will, in many cases, try and drive the interest of their sponsors, right? So the voting population has been polluted before it can be manipulated by the hierarchical structure of the actual system. So I'd say it's pretty healthy. There's always going to be commercial interest. So a lot of the people who get to participate do so because of their funding from their employers. So they do drive agendas that are commercially beneficial to some of them. But you got to realize that the market forces also kind of fight that. So it's not like Cisco or Huawei or Ericsson can unilaterally drive something to standardization, because they will face scrutiny and opposition. So a little bit like a consensus algorithm, not as sophisticated and probably not as fair, but there is fairness built into the process.
Yeah, and that's kind of how I see the internet, is that the ideas there, you have a lot of engineering to drive it forward. We have a lot of the social org, the decentralization, consensus, democratic, driving forward, with maybe, still some commercial interests, intertwined with that. But for the most part, like, it's decentralized, it's open, and, it's democratic, right? Those are like three really big takeaways from the internet. And it's kind of like Bitcoin, right? Bitcoin was designed to be a decentralized currency, not as easily controlled by, central parties and stuff like that. But, that carries it to a certain limitation, like with proof of work with Bitcoin, that, it's still decentralized, but, there's a limited number of larger participants called mining pools that are really driving a lot of that protocol forward. And, that's where I
Right.
believe, you get you have the requirements and you have the idea and the concepts, and the first iteration will take it so far until you need to get to the next iteration, right? And Nexus is kind of like the next iteration of blockchain, the next iteration of the internet, taking everything that we've learned, just like, I don't really, I mean, I have my own opinions about Bitcoin and the architecture of it, but, ultimately, like, I respect the roots that we came from. If you look on our repository for Nexusoft, you'll see Bitcoin 1.0 is one of our pinned repositories. Just is kind of a reminder of where we came from, respect your roots. With the internet, that's how I see the same thing as well. I mean, without the internet, I mean, I don't even know if what the world would be like if we didn't have the internet these days. I mean, it's been an incredible gift to humanity, but then there's also been, a darker side to it, with, censorship and stuff like that, with, other platforms. So, and, commercial interests, and that's one thing that Victor brought up, during one of our conversations is, well, how do you prevent a big company like Verizon from monopolizing the network, right? How do you protect it against, big, large interests? And that's where we came up with the anti-monopolization barrier, right? Where we can mathematically lock the system to where you will only be able to deploy a certain amount of hardware before the network has to grow, right? You can only have a certain percentage of that hardware to prevent the monopolization of that. And what the goal of that design is to do is to really give people incentive to help other people grow too. Instead of just being, I'm going to be one company and get as big as I can, the company is going to start to recognize that if they maybe sponsor other companies or give startup seed fund, or, maybe share some technology, or, give reduced launch costs, or any of those things to help the network proliferate and the hardware, then they're going to end up being able to generate more revenue because they're going to be able to deploy more available hardware. So the idea of it is to shift this competitive model, which, competition will still always exist in systems, and I'm not against competition. I think competition is very healthy, but I do think competition can be a subset of more cooperative economies where you can, when you have just a completely competitively driven economy, then you're going to sometimes get a lot of copying of the same thing with slight alterations of it, right? Somebody's going to copy someone else and they're going to be competing. But, as far as driving new innovative things, it does drive them to an extent. But I believe that when we start seeing these more cooperative economies where, hey, I help benefit this other company and my company gets 10% increase in returns, right? You'll be able to start to quantify that. And I think that's going to really change a lot of the culture that we see things as, and change the culture of, the hardware deployment. And also, I think ultimately make it more profitable for everyone. That's one of the design goals, is to show people that as we create these exponential cooperative economies, right, Metcalfs, then it becomes more profitable than a linear competitive economy, right? And so you have competition and as subsets, right? Each company will have its own linear value streams, but those linear value streams get multiplied by other, economic, acts, such as, more people are wanting to deploy services on the satellites. That's going to drive the demand of the satellites, right? And then that could become a geospatial demand as well. So think about it. I live in the middle of New York City, let's say. That real estate that I have has a certain value. It has a certain economic value because I'm close to shops. But then when you start adding this internet economic value, now I can start delivering packets and do edge computing to people in my local geographic area, right? Within a square mile. Let's say a big company like Google decides to create a geospatial contract where they want to put, $10 million into deployment of the infrastructure in New York City for Nexus protocol that supports specifically Google services. So they're going to pay into this geospatial contract, and then the ground stations will be able to monetize from that contract by doing that edge computing or, content delivery or all those other things. So we're taking this natural, process that exists in the internet, localized content delivery, and we're applying that into this contract system so that you get, that's one way you can create this exponential value, right? Because we're multiplying the value with your pre-existing geospatial value and augmenting that essentially with this new, content delivery edge computing value, right? And that's how you start to monetize these ground stations. And then, you have the supply and demand curves of the satellites. So let's say then more people start to want to use the satellites, right? And there's only so much space available and there's only so many satellites available. That's going to drive the cost per byte up in that specific constellation. So now, you invested in, let's say a terabyte of data. at a certain return on investment value, doing an estimated valuation of however much per byte. Then when that doubles, now that initial investment as a satellite operator has multiplied by 2 or 3 or 4, right? And then what that's going to do is that's going to drive a higher profit, just like with miners, right? When the price of a cryptocurrency goes up, then it becomes more profitable to mine that cryptocurrency at the given difficulty. So more miners jump on and they drive the difficulty up. It's going to follow that same type of dynamic, right? And it's a well-proven dynamic already with cryptocurrency, which is cool. We're just, instead of applying it into this mining algorithm, we're applying it into routing, right? So that's how you start to get these multiple, exponential value streams. And that's where I think, when this becomes fully realized, the hardware's out, and we have a couple rings going, and more people start to see it, especially with the rising in censorship and difficulties with people, whatever opinions may be, there are certain apps that were deplatformed, right, for simply facilitating something that they felt was within their normal range of beliefs that they should be doing. They're deplatformed, right? And there's a lot of other people too that they want to make sure the information that they store is retained, ad infinitum. And also the web services and hacking. Look, the Keystone XL pipeline just got hacked, right? Meat plants just got hacked with ransomware, right? A lot of that is a symptom of the operating system architecture, because when they first built, DOS, right? They didn't really build it. They just took it from somebody. But, they didn't design it with all of the knowledge we have now, right? And as an engineer, and Victor's, I'm sure, very well aware of this, you just don't see everything that it's going to be used for. I remember me and Dean would talk about, you guys had no idea what packets were going to be used for in the future. You had some ideas. And as an engineer, you do your best to understand how it's going to be used, but really the only way to know for sure is to put it out in the wild, and then everybody will show you what it can be used for. And that's part of the beautiful thing about creating a type of platform, something engineering feed, is people show you. And so now, after this, what we've got 1980, about 40 years now since TCP/IP. Is it? We were doing, what was it, 5-bit addresses in the 70s.
Yeah,
and then moved to IP
40 years
in 80. Yeah, so about 40 years now of the internet, right? Which has shown us a lot of the, the things that work great on the internet, and then also a lot of the things that could be improved, right? Such as the need for border gate protocol for managing your routes and knowing the topology to prevent, loopbacks. And then what are some other things that you would list off? We have the security issue with address resolution packets not authenticated. Then you have packet sniffing too, such as my Wi-Fi packets can be sniffed from far away, right? If you use encryption, that definitely helps. But I've personally, played around with breaking WPA2 passkeys, and it's really kind of trivial. Even it's better than WEP. WEP used to be really easy to crack, but WPA still, you can capture the 4-way handshake, and then you just run it through a dictionary attack and you break that hash, right? And I've found some pretty difficult passwords with a good dictionary. You can usually find a lot of that stuff, right? And a lot of that is just a symptoms of adding these layers, just like Windows kind of started with XP, and then they're like, oh hey, anybody can control the shell and do whatever they want. Okay, well, we should probably add user account control. And then they move it up a level, and they start adding binary notarization, where you have to have a key and sign the binaries and stuff. And they're just adding layers, but the fundamental layer is still really quite the same. And that's kind of how I see the lower stack of the internet, is the fundamental layer. It works and it's great. And I'm talking about the physical link too, right? That's why we call ours the signal layer rather than the physical layer, because you're using signals. It's going to be completely wireless. And with the phased array antennas, that a really interesting byproduct of them is that you can't sniff the packets unless you're in line of sight, because the way a phased array antenna works is you have all these different antenna elements. Think of it as like a grid. Right. And then when you shoot your beam out, you could shoot other beams around that beam, and it shapes that beam with the interference. Kind of like if you drop rocks in a pond, you'll see those ripples interact with one another. So if you made one ripple and then you dropped rocks on the side, those ripples are going to push that one original ripple and kind of shape it, right? That's how a phased array antenna works. It's just doing that with radio waves. And so what it allows you to do is to take this isotropic radiator, which is big spherical. Just think isotropic just means spherical, right? And turn it into a beam, kind of like the difference between the light on your roof, that's just isotropic radiation, and a laser beam, right? The phased array antenna is kind of like a laser beam for, you know, our radio frequencies. But the other really unique characteristic of it is when you're dropping all these rocks, when you're creating these ripples to shape that beam, then if you're trying to sniff packets, you're just going to get the noise of the spill off. You're going to get all that spill off going. So you're actually, to get that line of sight, you have, or to sniff those packets, you have to be directly in that line of sight. It's like the laser beam. You have to intercept the laser beam. With conventional packets, they just kind of isotropically radiate out, right? And then the other really important quality too, which is something that I'd always really wanted to figure out. And I had some ideas with proof of work, if you remember that, proof of work to stop DOS attacks. And that really kind of helps you for a single point DOS, where if you have a lot of requests coming in and that request is computationally intensive on the application layer, then you can do a type of proof of work that will, you know, require the person submitting computationally intensive requests to have to do computation themselves to bottleneck them, right? But that only works on the application layer, right? Fundamentally, on the router, if you're under a really severe DDoS attack, and correct me if I'm wrong again, from what I understand is that you can't drop the packets fast enough inside the router. The memory only has a certain clock speed. And so you just get bombarded with packets and it saturates essentially your line. And there's really not much you can do other than just make the routers more capable, right? And
Yeah,
you know,
it's legitimate traffic, but it's basically designed to overwhelm the router, some resource. You pick, there's many things you can denial of service attack, but yeah, that's absolutely right. So yeah, I mean, those are some of the interesting things of all the radio frequency research that has been done so far.
Yeah, the phased array antenna being steerable, right, to get on the DOS attack, that allows us to, on the base layer, on the signal layer or the physical layer, to cut off. So you actually just point your beam in a different direction and you've reduced the impact of DDoS attacks. So, you know, a lot of these issues that we've seen, and they're, you know, things that Dino used to say, like, oh man, that's what keeps me up at night. And I'm like, I'm going to figure it out, man. You had a solution to it, you know. And, you know, over time it's really cool to see how it's all kind of formed together. And now, and you know, yeah, I'm really grateful to be working with you on this, Victor. And
likewise.
You know, yeah, I appreciate having, you know, someone with such vast experience to be working with on this. And I mean, also, you know, you and Dino I remember we'd have many conversations about, you know, some of the issues, you know, you'd talk about with criticisms of border gate protocol and things like that. And not a lot of IETF people think that way as well. A lot of people have just, you know, just taken it as, hey, you know, it works. Don't, why does it need to be fixed if it, you know, doesn't break or anything like that, or, you know, it's already propagated or it's already there. But, you know, I appreciate, you know, that you guys have that extra eye too, and have seen those things that need to be addressed and fixed. And, you know, I'm really excited to see this whole thing come to fruition, especially, you know, weaving it through an operating system was kind of like our final element, you know, as he said before, you know, the TCP/IP stack wasn't really adopted very much until they embedded it in Unix, right? When you embed it in the operating system, it embeds it everywhere. And, you know, same with locator identifier separation pro. It's going to essentially be integrated directly in the operating system with a software defined router. They can just be simply updated. And then, you know, that's why we're first iteration targeting the Cube satellites and the IoT devices, so that we can start having, you know, really useful geospatial systems, right? When people start talking about, hey, I want to have a meat truck and I want to know if the temperature in this meat went below a certain period of time, you know, to know if this batch was bad or something, you know, with supply chain tracking. And they usually talk about, you know, IoT and blockchain. Well, this marries those together, where you have IoT combined with blockchain with the satellite communication, all wrapped within this geospatial system. So, you know, supply chain tracking is going to become very, very powerful with this new protocol. It's going to have, you know, possibilities that, like, you know, like we said, we can't possibly imagine everything that is going to be used for. But, you know, one of the elegance, you know, at least my opinion of the elegance of the solution is the simplicity. And that's what I'm always striving for, is to create the simplest solutions that have the most powerful capabilities. So if you can make it simple and powerful at the same time, then you're going to be less prone to bugs. It's going to be easier to maintain. Other people will be able to understand it and add to it. And you have less going on the hardware that's required. And that's something that's really valuable, because going into cube satellites and IoT devices, we're kind of back in 1993 again. As far
Right.
as like you have to think like you're in the 90s again. Not to say that this is the computational capacity of 90s computers, but you got to think, limiting your bandwidth. Right now, people are used to 5 gigabits, 1 gigabit, ridiculous download speeds. And I remember once I was like, oh well, I'm just gonna put it over the network, and I was like, oh wait, I'm sorry, dude. He's like, it's okay, everybody abuses the network. I always remembered that, because everybody, we just see the internet is working, and it's like, oh hey, well, I'm just gonna make the network do it. I'm gonna make this other stuff do it. And so the network takes a lot of abuse, right? And people put a lot of that stress on it, just by the protocol implementations. Even using a hypertext protocol versus a binary protocol, right? You require a lot more data throughput. So I like that it fits in with kind of my style of coding as well, which is just make it very simple, make it very fast, and an elegant design that maps to many different things in many different uses. Like the geospatial routing system fits in with geospatial contracts and content delivery and edge computing, and it just, all of these things is just mixed together really beautifully. So yeah. Is there any other comments that you wanted to drop in, Victor, before we close this section of the?
No, I'm just wanted to say I'm excited at the opportunity. I think you've described it in very colorful detail, and it's going to be good to put in practice some of the stuff that we know can work. So yeah, excited for it. And to your point, this is where we break molds and where we innovate without having to necessarily heed way to the old laws of physics. There are things that may require new frameworks. So looking forward to it.
Awesome. Yeah, well, welcome aboard. And I'm sure, everyone else, will say welcome you as well. We appreciate the time that you volunteered over the years, and we're happy to have you on board. So everybody, so what to look for next, we're working on the OneStack white paper, where that's going to get into more details. The first white paper was kind of the introduction to all of the core concepts. The OneStack paper is going to really drill into, what each specific layer functions for. We're going to drill into wide radius locators, more geospatial locators, and a lot of these really colorful details, like some that we've explained here. And then, we're going to be, from there forward, we're going to be, at least from my perspective, we're going to be borrowing a lot from like the RFCs, right? If you remember, requests for comments, I started reading the first 10 RFCs just for shits and giggles. I was like, oh my gosh, 5-bit addresses, man. It's cool. But it's like, the very first ARPANET RFCs. But I want to borrow a lot of those concepts, with the requests for comments, and developing, spec documents, probably with like a little bit more than the text, the packet, but modeling it down pretty much to the packets and to our bits, and all of these specific aspects. What exactly does a wide radius locator have in it? What exactly is a geospatial locator? So that we can turn this into pretty much a specification document, which is going to be a series of white papers. The first one is just the OneStack, and then from each one of there, we're going to be drilling it down into something so that other people can essentially start replicating the protocol as well. And like I said, we're borrowing a lot from what worked at the IETF, what works on the internet, and we're pushing the boundaries into a new way, a new type of physics, a new understanding of how we can make these things happen. And hopefully we get, if it's even 1 million more people than 2 billion than the current internet. Even if it's the same amount of people or half the users, it will still bring a lot of benefit to people, because ultimately, with it being gamified, you'll only have to buy the hardware. You buy the hardware and you connect to the net. That's it. Right now you buy the hardware and you have to pay a membership fee. The idea of this is that you just buy the hardware and you can turn that into something that you can generate income with. And with a lot of the economic disparity that the world's in right now, I believe this is going to be very valuable for people to be able to have a new economic system that they can plug into from anywhere and contribute to. And so, yep, we're definitely happy to have you on board, Victor. And I always like that you appreciated and understood the humanitarian aspects of it, talking about Venezuela and helping, different areas that are impoverished and providing, by providing opportunities for people to generate that income where they didn't have it before. Because that's the biggest the difficulty with economic disparity is just lack of opportunity. So this, is here to generate more opportunities for people, and, deploying the hardware yourself, maybe deploying your own local ISPs in your local areas, or deploying services, or, providing edge computing. And I mean, you'll basically be able to start turning your computers into, a business where you can start earning money just from running it. So it's kind of the concepts of mining where, just running this computer program, I earn money, but without all of the computational intensity. So,
right. Fantastic.
Awesome. Cool. Well, thanks again for joining. We do these quarterly. So we'll probably, just to keep everybody up to date. So yeah, we'll be coming on again, I think, what would it be, September from now? And we'll be discussing things, and you'll obviously be seeing more, papers being written out. So I guess that concludes the Victor section, unless you got any further comments, Victor?
No, thanks. It's been
all right. Thank you.
great.
All right, everybody. So now, okay, I'm really excited about this. So I wrote a query language. I wrote an SQL in the last few days. And basically it allows us, I'm going to share my screen. It allows us to basically list anything. So Nexus now has search. Like this, as far as I'm aware, nobody's been able to really succeed in this. You can search for anything basically on Nexus now. Let me share screen. This is something that I've been particularly excited about. Okay. Sweet. Okay, so I just finished this today. So it's a recursive query language. So as you guys are aware, you have different list commands, right? So if I'm over here, let's say finance list accounts, let's do. So I've got all these different lists, right? This is going to give me just a list of accounts that I own, things like this. But as you see, this is your result JSON, right? But each object itself has its own data members, right? An object register is basically a programmable object. So what I've created now is a query language where this right here, all you can really do is say, hey, I have a session. This is just, I want to limit, I want to count, and, that's it. So what we've created now is your ability to query recursively. And I borrowed a lot of the SQL syntax to generate it, but essentially you can create a query on any object. So in this specific one, let's say using a wildcard, register list accounts where object.name equals D asterisk. So what this actually does right here is this is going to return you every single account on the chain that start with the letter D, right? And this wildcard character allows you to do a preceding wildcard or a wildcard that appears afterwards. So what you're basically able to do now, and this is going to be coming out in this next update 5.1, is you can create essentially like any type of search functionality. So when you create, let's say, an asset, I want to create an asset, and your assets for your app that whatever, it's maybe a for sale asset, or maybe it's an asset bounded to a geographical area. You'll be able to add tags into the asset, into the object register, and then you'll be able to search based off of that, right? So essentially, this is a really big, important step towards decentralized search, because web services that are stored on Nexus are going to each have their own register, right, as the object that represents the metadata of that specific file. So that's going to contain, your file's address. It's going to contain names. It's also going to contain checksums. So if your file is encrypted, you'll have a ciphertext checksum and a plain text checksum, right? So in order to search, you need to have some way to find assets by some sort of mechanism. So this basically is what birthed the SQL language, right? I actually started it because I guess I should rewind a little bit. I'm sorry, I'm excited about it. Basically, I started going through the API code. I've been working on Tritium++ and LXOS most of 2020. I built the constant time database, which I got that up to 450,000 requests per second. Multi-threading in the memory map pages, I got that up to actually 2.7 billion pages per second. That's not off a disk, that's just using the virtual memory, right? But I got some really significant speed improvements because I started basically going into the lower level database again because it was the beginning of 2020 when the pandemic hit, and I just had this thought. It was just like, oh crap, man, we're gonna need this really soon. Like some stuff's about to go down. So I was like, okay, we need to get this ready for global scale. So I started this scaling test, and that's where I hit about 10,000 contracts per second on my local computer to test out, how much the system can handle. And from that, I started finding bottlenecks. And one of the bottlenecks was that over time, I would start to lose my performance, right? I'd go from 100,000 contracts per second to 80,000 to 70,000, and it would just start degrading more and more and more. And the current lower level database, as it stands in Tritium, was designed to be somewhat constant time, but you still had to iterate through the different hash maps, right? So now we've got the constant time database. Then fast forward. So then I was working on basically Tritium++ and a lockless library. So I started working on lockless data structures, which eventually turned into kind of more fine-grained, fine-tuned lock to just have really fast, efficient, concurrent data structures. So that drove me into basically go down a deep rabbit hole, working on lockless queues and compare and swap and just learn about all that stuff, right? And then basically we ran into an issue with CoinKit, where CoinKit suffered a failure because their API, for whatever, not for whatever reason, but they had a sig chain that was 85,000 transactions. And, by the way that the API was designed in the previous update, is it had exponential time, which means if I'm loading, let's say I'm just listing my assets, right? When you list the asset, it would actually, for every asset you list, it would scan the entire sig chain again to find a name record associated with it, or the number of transactions, or just kind of superfluous little pieces of information, and no indexing whatsoever. So when you have this exponential time, right, if you only have 10 iterations, that's not bad. You go from 10 to 100, right? You increase it by 10. But when you have a sig chain of 100, now you're at 10,000. When you have 1,000, now you're at 1,000,000. Right. So it combinatorial explosion. It explodes in complexity because you have to iterate, that amount of times for every time that you're doing it. Right. And so that ultimately resulted in a hardware fall, from the best of my understanding, a hardware fall, which, corrupted their next hash. So that was like, okay, well, what's going on here? That's when I stepped in and, ultimately some of those discussions, basically I started looking through the API code and reviewing it. And, that's when, I was like, whoa, Paul, like, what are you doing here? And that ultimately led to Paul just saying, okay, it's too hard for me. I don't want to do it anymore. And that was that, right? So that drove me into the API code. And so since that date, it's been about a month and a half now, is when I started working on the API. And at first it was kind of like lots of stuff that just needed to be done that you didn't want to do. That's like not the funnest stuff to do. And just a lot of copying and pasting. And like a lot of it, some of it is remnants from the code I create. Because I started the API code in January of 2019. We had, a lot of use cases that we were doing demonstrations for. So I just quickly threw together some code to make just a basic API interface so that we could start showing demos, right? And then Paul, I think, in March of 2019, April, took over the API development. Now, I had hoped that he would, improve it, but he did do some cool stuff with like the objects API. He did good on that, and notifications processor. That code was fairly good, but everything else was just like just not really well thought out. Things were shoehorned into things, exponential time algorithms. And so when I started to really dig in, I was like, well, okay, no wonder there's a problem with CoinKit, right? Now, don't be afraid, anybody. It's not an issue with small sig chains. It's only an issue with really big sig chains. So you'll start to notice, I think we're at about 1,000 transactions, 1,500. Like, it takes a bit to load my transaction history on my wallet just with the US sig chain, just because of the nature of the design, right? So, ultimately the API didn't handle scale very well, right? So that drove me into this whole exploration of the API code, and just really cleaning up a lot of stuff. So there was a lot of like copy and paste code. You're building the transaction in a copy paste every single time, which just, it's really difficult to maintain when you have copy and pasting code. One reason you don't want to do that is if I want to change logic, let's say, in how I generate a transaction, and I have a copy and pasted code for every API call, I have to go to every single API call and change that. And that's really bug prone and error prone, because I could change it in 9 out of 10 and then miss that one and then not realize it, right? So you want to have every code unified in a point where you call functions that are reused many, many times, right? That's really important in code quality. So I started out with that, which is just cleaning up all this stuff. I found a lot of bugs in the finance API. Things like credit didn't work. So I started writing a lot more unit tests to get that and really cleaning it up. And then I kind of turned it into generic methods, right? So I took, there was a lot of like, finance list, object transactions, finance list, account transactions, finance, and they were like mapping one actual function name to different functions in the actual C++ code, which still wasn't very well maintained. It is a lot of copying and pasting still. So I focused and I created this generic list commands and generic object handlers and stuff. So, I've gutted out so much code that was just complete copy paste, didn't need to be there, and really went through the tokens in the finance API. And I added some nice commands such as finance debit any and finance debit all. So what both of those do is finance debit any allows you to send a mix to a mixed recipients. So I can say, hey, I have, a token account and a Nexus account. And, let's say I'm in an exchange and I'm managing multiple Nexus tokens on that exchange. You can just do finance debit any, and you just put in the recipients, and it allows you to do a mix and a match of any of those. Another thing that the API didn't have is batching, right? So anytime you'd create a single debit, it would do one transaction per debit. But the way that, we get aggregation in Nexus is we had basically 100 contracts available per transaction. So that's what I started with the finance and the tokens APIs. I wanted to clean up all of that code, and I did that to get CoinKit online. But the first step was I needed to add batching. And in order to add batching, I had to clean up all this copy and paste code, because otherwise I would have to add the batching logic in every single call that needed it, right? So that got all done. Finance debit any, finance debit all, really nice and clean code. I pretty much, on average, I'm cutting the code in half for the same functionality, if not more functionality. And that's good. Contrary to what you may think, you want less code to do the same thing. You don't want more code. More code means more bugs, slower, more processing, and just less maintainable, right? If you can do the same thing with less code, that makes you a better programmer, right? And you have to be, smarter in the way that you apply things to do that. So that ultimately led me, I got CoinKit online by adding the batching. So I added a new mode called Auto TX. So you guys will appreciate this, because right now when you generate a transaction, you have to generate the keys and the whole thing, and then you get the TX ID back and everything. But if you're just using your wallet, you don't necessarily need to build the transaction and know that it's broadcasted right after you create it. You can have that go into the background processing, because you have your notifications processor that's processing. So that's what Auto TX does, is it aggregates all of your contracts up to 100 contracts per transaction, and it processes in the background. So when I do a finance debit, any, or finance debit, account, or finance debit token, or whatever, right now, it instantly comes back, right? So your transactions, when you use Auto TX, will instantly come back. So you've freed up to go do more stuff in your wallet at that point, and then it processes that transaction in the background, and it batches that. and it pushes it to the same notifications processor point. So it's generating the same transaction. So it can mix the debits and the credits in there. So that became really valuable for getting CoinKit online. I mean, we had to reconstruct about 24,000 accounts. The reason that we had to reconstruct is they didn't have a recovery phrase enabled. Unfortunately, Paul never alerted them of that, which ended up costing a bit of money, but it is what it is. So ultimately got them back online. I think I got them reconstructed with about 200 transactions rather than 50,000. So if we did 50,000 transactions, we were right back to where they were before, right? So we needed to have that batching done. So got them back online, got the batching flowing, got AutoTX in. And what I'm adding now too, since we have all of the transaction logic pushing to the same point, right? You've got the same function that's managing all of that. I basically just need to add one little bit of code in there for safe mode. So I'm adding a safe mode parameter, which allows it basically before it broadcasts a transaction, it first calculates the next hash, like it's the regular transaction. But then before it broadcasts that to the network, it's going to recalculate that next hash in another region of your memory, okay? Because you need to protect against hardware faults. So you don't want to do it in the same piece of memory. You do it in another region of the memory. You recalculate that next hash, and you make sure that they're equal, right? So this is going to protect against any corruption, which comes from a hardware fault. And that is, one issue that I've seen, architecturally with this chain, which is why we recommend having a recovery phrase enabled, is it can happen. You can get a hardware fault. And if you get a hardware fault in the middle of that hash, it's near SOL, right? So that's why I'm adding safe mode in there. So basically safe mode is going to double check afterwards. And then if you're running safe mode and AutoTX, you're not going to notice any difference. If you're not running AutoTX, it'll take about twice as long to produce the transaction, right? But if you are running AutoTX, it's just going to process it all in the background. Another aspect too is transactions in the API were not saved once they were broadcasted. So if I, broadcast a transaction, if I change my password, but I don't have any connections to my nodes, that transaction is not going to rebroadcast. And once you restart the app, then it's poof, it's gone, right? Because it's only stored in the memory pool. It's actually not stored, it's not stored on the disk, which that's a bit of a problem. We've seen a couple bugs with that. So I'm fixing that so that you basically save the transaction on the disk. And then, I've been going through, I cleaned up a lot of the commands code. So it's got a really nice, it's kind of like, the API is kind of like a bunch of Legos, but what I did is I created Legos for Legos, if that makes sense. I mean, basically what you're doing is you're generating, there's all these different objects now. So for somebody to build an API, it's really easy now, right? You just register your API, you add a couple methods, you register some functions, and you register some objects. And that's it, right? It's completely generic, completely open. Before, it was kind of like you manage the objects through the specific function call, and it worked to a point, but the API has been kind of limited. So I'm happy that I've been coming into the API now and really bringing a lot of it to light. One of the things that was really important now when I was going through is I was just like, okay, well, we have this finance list trust accounts, right? Same thing, list trust accounts. So you manage the object, the state, and everything in this one method. I was like, okay, that's retarded. We should just have, a registers API register list, and then I should just be able to say trust, right? Or registers list accounts, or registers list names, or anything like that. And boom, that's when I created that first one. And then I was like, okay, well, I need to set it where I can search by a token. So I added that parameter in, and I was like, oh wait, you know what? Let's take a hack at this filtering stuff, right? And so I started looking at the SQL syntax, and I really it started out simpler, but I over the weekend I was like, you know what, it's got to be beautiful, it's got to be generic, it's got to be powerful. I was like, I'm just going to do this right the first time. So I just finished that yesterday. Okay, now this is a really powerful query language. Okay, so let's say you've got a SafeNet service and you deploy it, and your SafeNet service has a TNS entry, and it's got, another, checksum and stuff that represents the main site. Okay. How are you going to search? no search. Blockchains don't have search. There's no search functionality in blockchains anywhere, right? The only way you get search functionality is if you take the blockchain data and you dump it into your own SQL server. And that's what block explorers do, is they're pulling chain data and dumping it in an SQL database, because SQL, which stands for structured query language, allows you to search, right? That's one of the big main points of an SQL database, is you can search specific fields of data. One of the really important aspects of the data is wildcards, right? So I'll just kind of segue into here. I'll start with supported object. So when you create a query, as you see here, you have object.name. So object denotes that it's a raw object register, okay? Then you also have a results object. So this allows you to filter based on the JSON results. Like I said, it's about 10 times slower, so use sparingly. But this allows you to essentially operate and create conditions on the specific binary data. So if I have an asset where, you know, it represents a SafeNet service, I can have a tags field where I could just say register list objects where object.tag equals, then I do asterisk and I say hello, and then another asterisk, or Nexus, you know, and then another asterisk. And that'll search every single object in Nexus that has that specific character encoding, right? That has that specific set of characters. So that's really, really, really powerful and really, really important, because we can now search anything on Nexus, absolutely anything. Even if you don't declare a tag, right? You can search by any available data field. Let's say you have an object register that represents your title for Arizona, or a title for the United States. You can literally search registers list objects where object.region equals AZ, or US, or whatever else. Or you can do a list of them where it equals US, or object.region equals AZ, or object.region equals UT, or whatever you want, right? And so the beautiful thing about this query language is it's not just like I can add a couple filters and whatever. No, you got a full query capabilities now. And it doesn't have any limits to the depth and complexity of your queries, right? So this is a wildcard, as you see. This is showing a proceeding. So this above right here, register list accounts where object.name equals D asterisk. This is going to return all accounts that start with the letter D, every single one of them, right? This one right here is going to show you all of the objects that end with a letter D. As you see, the asterisk denotes, you know, either one or more characters, right? So you have D and then asterisk, which says it can be any character after that. This means it can be any character before that, right? So this is similar to kind of a select statement. If you're familiar with the SQL syntax, except this is kind of like your select asterisk, right? The register list is kind of your select, and each one of them, you know, it's got its own different API, right? There's different types of objects. So, you know, this, I didn't really decide to go full SQL because it just didn't really make sense. We don't really need, you know, the update, select, and then you don't really need to select the specific fields you need and stuff like that. I just didn't see any point in that initially, right, for this initial implementation. So let's show some examples. So register list names, right, where object.namespace equals an asterisk global asterisk, okay? So a global name has a namespace of global, right? So it's actually, let me see if I think I had another one down here. Yeah, this is what a global name looks like, as you see here. I just wanted to show this one using wildcards so that you could kind of see the wildcard syntax. But so this is saying I want all global names that start with a capital P, or I want all names that start with a capital S, okay? That's what this statement does here. Now, when I mean that you can do infinite amounts of complexities, right? This set of parentheses here is a grouping, okay? So the way that I designed the syntax, and this is how the conditional virtual machine is as well, is you can't mix ands and ors. And that's just to prevent people from making logic errors, because there's a certain order of operations that are required when you do an and and an or, and it's going to just group them naturally in the way it processes it. But I didn't want people to be able to make that mistake, right? If you remove this, you know, let's say we remove this parenthesis, what is it? Is it object.global, you know, that namespace equals global and this or this, right? Or is it this and this or this, right? Do you see how it just, you can get it's the compiler doesn't really know what you're intending. So it's a very explicit, strongly typed language. You have to know, you have to group it specifically. And if you just do something like, hey, object.s, or object.name equals s, and you do it in parentheses, it's not going to let you, right? You have to, it's a very picky language. And that's just, you guys will learn that the more you start using the languages I make. The way I code, be explicit as possible. Don't be implicit, which means you don't leave the compiler any room to assume anything, right? So I'm not a person that likes assumptions. So this is, assumption free. So basically you have to denote, if you're doing a mix of an and an or, you have to denote some sort of grouping. If I took these parentheses out and I just executed that statement, it would fail. It would send a syntax error, right? Because you can't mix ands and ors. It's really important. Okay, now we can filter with multiple operators, right? So this below here, this is where it starts to get really powerful, because you can do less than, greater than, equals to, or not equal to, right? Or less than and equal to, or greater than and equal to. So that's kind of 6 operators, I guess. So this right here, registerless accounts, where object.token equals 0. So remember, when we're choosing object, when we're doing object dot, that's a binary operator, okay? So when I do this and I check for every single object in the chain, like the entire Nexus blockchain, this query right here would execute in about 100 milliseconds, which is pretty quick. But if you go and you use result instead of object, right, where you're actually filtering the post-generated results, it's about 10 times slower, right? So when you're filtering the JSON data, it took about 1.5 seconds, which is, there's not much use for needing to parse the results or to verify off the results, just because most of the data you need is in the actual objects themselves. But I left the results as an option just for people that want to play around with it, right? Because there are some needs for it. So these are the supported objects that I created the last few days, right? But obviously, this is not going to be what is the final tally. You're going to have contract, you're going to have transaction, you're going to have block, right? They're all these different types of objects, and they each have their own kind of generic object handler, which is really beautiful, right? It's really simple code, really powerful. I think I did all of these filters, maybe 1,000 lines, if that. It's less, probably each function is like maybe 100 lines, like each of the recursive functions, because it's done with recursion, right? Which I'm not a big fan of recursion, just because you get stack overflows, which means anytime you call the function itself, you're adding more to the return value, you're pushing more and more, and you'll overflow your stack at a certain point, right? And it'll stop working. So, and also it's just like, why use recursion in place of a loop? Just to use recursion, you're killing your stack. So I never really found a strong need to do recursion, but this was a really great use case for recursion, right? So, anyway, I'm getting a little ahead of myself. So we got this. Okay. So now we're filtering with multiple operators. So this here is object.token equals 0. That's Nexus. Okay. So Nexus, is token identifier 0. As you guys are, I'm sure, aware, tokens on Nexus or Nexus transfers, if they're the same thing. I know Ethereum was wanting to do that. That was one thing that they realized down the road, is that, wait, native Ethereum can't interoperate with ERC20 tokens, and ERC20 token contracts as easily, unless it was an ERC20 token type, contract, right? So they kind of didn't really, they kind of ran into the shoehorn issue, right? Where it's just like, add more functionality, add more functionality, add more functionality, add more functionality, but not really reassessing or assessing their foundation or assessing their initial architecture to support all of that added functionality. And that's kind of what happened to the API, is it just, add functionality, add functionality, add functionality. And there really wasn't a lot of thought put into like, oh, hey, is this algorithm efficient? Or like, do we need this? Or, and it just kind of like added up over time. So it just got to a point. I mean, it's not for everybody, this type of code, right? It's just not. I mean, it's high stress. I mean, how do you make a diamond, right? You make a diamond under extreme pressure. And that's kind of how it is, right? It's just, to build something great, you're gonna it's not for everybody. It takes a lot. It takes a lot of energy. It takes a lot of forethought. I mean, me myself, I've a lot of my life has been completely based around, Nexus, and, getting myself more capable and more knowledgeable to be able to fulfill a lot of these things that I've wanted to fulfill, right? Back in 2014, when I first started building it, I had a fraction of the knowledge that I have now, that I've been able to muster and create from that. So it's not for everybody. So, blessings and, blessings to Paul, like, it's difficult. So, but I'm happy on the other side of it that, I've been able to really kind of dive into the API code and, fill in some voids that I felt were kind of missing. And this filtering thing is a really, really important aspect because, right now on the wallet, if you see, you can filter and sort your transactions. But that's all done through lazy loading, which means they're basically loading from the API into the logical layer, and then they're sorting everything in the logical layer. That takes a lot of memory. If you have a large SIG chain, you're going to notice it takes a long time for the transactions page to show, right? It takes, there's a delay, a noticeable delay, because you have to lazy load all of those transactions because they have to apply the sorts and filters, right? There's no sorting and filtering built into the API until now, right? So this right here is going to show you every single account on the chain that has a balance greater than 10 Nexus, right? That's where you start getting really, really powerful, queries. Basically, is I can query any account based on the token identifier, decimals, any parameter, data, tags, balances, just anything. And the really cool thing is there's no limit to the recursive depth now, right? Originally, like 3 days ago, I just made a depth of 2. I was like, okay, I'm just going to lock it at 2. But then, my initial creation recursion function wasn't really like what I wanted it to be. So I went through a few iterations, over the last few days until I finally got something really nice and sweet. I think it's like, what was it? 70 lines, I think, only under 100 lines for the recursive grouping and handling, right? So it's very simple, very quick. Now we can add to this where we start to create these logical grouping, right? So this is where I start showing you multiple groups. So this would say list all of the accounts where the token is 0, so that's Nexus, and the balance is greater than 10, right? So that's going to say list me all Nexus accounts that have more than 10 Nexus in them, or list me all accounts for this token that have a balance greater than 1, right? So as you can start to see, you get really powerful concepts here. When you can basically use Nexus like a database. You get the functionality of a database, a relational database. You can read data from data, right? And you can filter out pretty much anything. You can filter any object that's supported in Nexus: transactions, blocks, object registers, state registers. You can filter out by state, by conditional contracts, and all of that, right? And you can even get in these really complex queries where we have this. So this, we have multiple logical groups, as you see. Register list names, and now we have the object name starts with a D and the namespace is global. So that's saying list me all global names that start with the letter lowercase d, or list me all names that are inside the send.to namespace that start with the letter E. Or yet again, list me all names. Let's see. List me all names that end with the letter S. So what this statement says is give me all of the global names that start with a lowercase d, or all of the names from the send to namespace that start with the letter E. So that's going to give me both of these sets, this one or this one, right? This and logic means that both of these logical sequences are required. So I want all names to start with a D in the global namespace, or all names that start with an E in the send to namespace, or all namespaces or all objects that are in a namespace that end with the letter S, right? Now, this is a 3-layer recursion, but there's no level. There's absolutely no limit to the amount that you can recurse, right? It continues to just go and go and go. So as you can see, the possibilities are endless, right? This is just the basics right now. Like, this is just me building queries off of data that already exists. But once, people start to recognize that you have this whole query language now, right, which basically is turned the Nexus API into an SQL database, a mild SQL database, right? You have the power, the query power of an SQL database, especially with the wildcards. That was a really, really important thing. That allows your search. So, you create a SafeNet service, you put tags on it, you tag your assets, you tag accounts. You write an article that's on your article site, and you just say, service is this, or you just say, hey, this SafeNet service is owned by this Genesis ID. So I'm going to search for all assets with the owner of this Genesis ID and a tag that equals whatever tag you want. And boom, you have search in your DApp. You can search anything inside your DApp, which is great. So depending on how you decide to tag it, you just have these infinite capabilities here, right? So this is a really, really, really powerful language. And I'm glad I spent the time to get it right. It's taken a little bit more time than I anticipated, just because I didn't anticipate, how much work there was to do in the code, but it's really come a long way, right? I'm really happy with it, especially with this query language. And you guys will be really happy with this too, because I never liked parsing. Okay, I'm not a big parsing guy. Like, parsing is like breaking up a string, right? Like, I would parse this, by spaces so that I can break it up into, different objects, right? That I can start operating on. And then I got to parse this by the periods that I can say, oh, well, this is object, and then this is the field balance, right? And then I got to parse this out. Like, parsing is just basically turning strings, which are just character sets, into usable objects, right? Into usable information. And I've just never really liked parsing. I don't like I don't like what would be hypertext protocols like HTTP. It's just not my thing. I'm a binary guy, right? I like zeros and ones. They're efficient, they're fast, don't have to parse, don't use delimiters. Like, I don't like delimiters, but I finally was just like, okay, I have to do this parsing to get this really an effective query language, which you guys are gonna be happy with, is really most of what I need to do for conditional contract programming language, right? So that's what I'm doing next, which I'll probably be doing a little later tonight or tomorrow. Also, if you're developers and you want to help me test this SQL, it's pretty much there. Like, the tokens and the finance API are fairly well complete, and the query language, for registers list and a few other ones. That's all fairly well formed, but the rest of the APIs I haven't fully gone through because I've been working on the foundational stuff, right? Like, extract parameters, extract functions, filter this, blah. I'm building all these building blocks for the API so that as I go to the other commands now, I don't have to be like, oh, hey, there's this, multiplied functionality and I need to find a generic way to handle it, like with the URL rewrite or whatever. Now, a lot of that's done. All the building blocks are kind of in there in the API. So now it's just kind of like taking those blocks that I built and piecing them together. So if you're a developer, I'll probably be wrapped up with the rest of the API commands. I'm shooting to have it wrapped up by the end of the week so that we can have this out in a pre-release and testing so that people can start utilizing it. Along with that, I'm going to be including the conditional contract language, right? Which is going to be a very basic syntax to start. But what that's going to allow you to do is start to write conditional contracts in regular human language, right? Since I got fairly decent at parsing while I was working on all of this stuff, I found some really nice, really efficient ways to do things where I'm like, okay, I don't hate parsing so much anymore because I found some nice ways to do it. But until basically until now, like, we hadn't had this DSL. So what this update is, this 5.1 update, it's pretty much Tritium++. Okay, it's Tritium++ in the API. It's it's adding a lot of functionality with like your query language and your domain specific languages, right? As you guys remember, a Tritium++, or it might have been an Amine feature, is domain specific languages. So we now have a query domain specific language that's completed. Now I'm going to write a conditional contract domain specific language, because what we want to do is we want to get a lot more API functionality. Right now, the API really doesn't expose all of the functionality of Tritium. And it's really explicit, which is like, oh, I want to do this specific thing. I have to create a whole new API command for it. It's not really generic or powerful, right? You have to like, oh, tokens list token accounts, instead of register list accounts, where token dot, or object dot token equals whatever, right? So as you can see, like that explicit copies of all these functions, right, kind of limited the capabilities and the power of it, because you had to program something to make that work. To add more functionality in the API, the conditional contracts are hard coded byte code that you just say, oh, I want to set the expiration on it, right? There's not really a sophisticated capability in that. And I think that's limited a lot of the development capabilities of this stack in Tritium. So that's why I put the time into this. It originally was just, I'm cleaning up this, I'm getting it ready for client mode and all of that. But then it kind of drove, I honestly, I'm not going to lie, I needed something creative and awesome to build. I just needed, like, that's why I built this query language. Like, the way I work is it has to be awesome to me, like I have to be able to geek out and be like, oh my gosh, it's so beautiful. And because of that, I create, beautiful things, at least to me. But, when I have to do like dealing with uglier stuff, I have to have something really cool to be motivating me with it, right? So this query language really kind of was like a bow on top of it, as I saw finance list trust accounts, and I was just like, oh God, this is just so ugly. Okay, maybe I'll just add, register list accounts with, a generic token, where you can just select by token. And then I was like, well, maybe I want to add, another clause. And then I'm like, well, but maybe I need ands and ors, and then poof, here we go, SQL, right? So it's a good thing. I'm glad that it expanded into this, because like I said, especially for bubble developers can't sort and filter. They just can't. They rely specifically on what the API gives them. And we've got a lot of people that are building on bubble now. A lot of people are starting to get involved on that. So we wanted to really improve the syntax and capabilities of bubble and really add another dimension to web applications. So that's one really big thing that's coming out in this next update. And then obviously the conditional contract programming language. And those are going to be two things to expect from this first 5.1 is what it's going to be released as. And then 5.2 is the next update, which what I'm doing there is I'm adding an API level indexing. Right now, there's really no indexing. So, if I want to find all of my accounts, I literally have to scan my entire sig chain. So if you got a sig chain that's 80,000 transactions, you can guess that takes quite a while to scan the whole sig chain. And then if I need to find a name record, like, I have to scan the entire sig chain again and scan this other sig chain and then scan a sig chain and scanning a sig chain and scanning a sig chain. It's just like, not good, right? So that's one reason it didn't tolerate scale very well. And then, there was also, a bug that, Paul was chasing about, like, you get a register from another sig chain and it doesn't know blah, blah, blah. And it's just because the way client mode works, like there's no API dedicated indexing. So he's just was chasing all these edge conditions around and creating all these phantom bugs. And it was just like, I was like, whoa, no. Like, we need to just reassess the architecture, right? When you're running into something like that, reassess the architecture. And like I said, the API iterating stuff was purely just for demonstration purposes. I'd always wanted to get the indexing put into it, but it just never really got there. So 5.2 is adding this indexing system in there so that you'll just, I want to list all my accounts. Instead of having to search my entire sig chain for those accounts, I just go boop and I download them off my local DB, right? So that's going to be really powerful for, my local database and, basically my functionality as a developer for supply chain stuff. And that's also, going to be the final piece needed for client mode. Client mode works right now, right? Like, I built client mode. There's a few edge cases and some scaling issues and, other things like that. So, that's why it's still in a beta right now, right? Like, it's okay in beta. But I don't want that released as like the end all be all, right? Just because there's still some bugs that I'm currently aware of that I'm fixing, for that. So 5.2 is handling a lot of that. And then it gets to our first hard fork, which is going to include the next hash scripts, right? Which is you can create, just like you see these ands and or clauses, right? You create an and or clause in your next hash to say this hash or this hash or this hash or this group of hashes and this hash or whatever, right, can access my sig chain. And then we can even, maybe not immediately, but we can even add, say, this next hash has this permission, of these bits that it has permission for. maybe we do 16 bits for 16 primitive operations. So that means like this next hash is authorized to do debits and credits, while this next hash is authorized only to do writes, and this next hash is only authorized to do all or something. So you're creating kind of like file system permissions in your SIG chain. Right? That's what the next hash script is going to do. But the really powerful aspect of it is you have this next hash and this next hash, right, in a single clause, and those have full permissions, let's say, or it's, the base one always has full permissions. So you got one key from this phone and one key from your desktop, multi-sig, right? So that allows us to start doing multi-factor authentication, okay? And that's going to be really important. People have been really requesting multi-factor authentication. I mean, technically right now, it's just as, secure as a Bitcoin wallet, because, the only way you can get compromised is to have the host operating system compromised. And, that could include having a keylogger. You get a keylogger because the host operating system is compromised. Okay. So when your host operating system is compromised, that means they have access to your file system, which means they can copy wallet.dat files. Okay. And they can keylog your password to get into your wallet.dat files too. Okay. So, it's pretty much like, I mean, it might, I'm not really, I don't want to push like too much. I mean, I'd say it's equivalent, if not better security than Bitcoin, just because of the key generation time. If you're using bit 33, bit 34 with your mnemonic phrase, they use a 512-bit SHA hash, which is really easy to compute. I mean, that's, sub millisecond, but it's about 2 or 3 milliseconds to generate a key pair. With us, you actually have to generate the key and the key pair. So it's at least 500 milliseconds. So we have a significantly higher brute force resistance than Bitcoin key generation, right? So we have, a fairly sophisticated security model, even using a login system. That's part of the beauty of the architecture, is it's a sophisticated security model with a simple interface. And that's what we really strive to meet. That requirement is sophisticated security, very complicated, what processes it is doing under the hood, but just a grandma just fine, right? You just log in and there you are. You got everything, right? That's the kind of interfaces that we strive for. So that's the multi-sig next hash script, okay? And then pooled staking. The pooled staking is going to be, it's going to use the same primitive operation, okay? So it's basically going to increase the security of the entire proof of stake system while increasing the availability as well for regular users. So that's going to be a really important architectural change. The implementation Scott did just was not good. I mean, that's ultimately kind of, he was supposed to work on it. It took him like 9 months. I mean, when I first gave him the architecture for it, I figured it would take him maybe a month. I thought for me, it would take me about a week, because it's not that complicated. You're just changing some things. It's really the same logic. A lot of the core logics there, we're just augmenting that logic slightly, right? So once I get this 5.1 and 5.2 out, that's when I'm going to be starting on that. And then we also have another developer that's in the process of being, well, actually 2 new developers in the process. One for the wallet working group, and then one for the backend to help me, right? And he's a very experienced developer. It's not Victor, it's another one that, again, very reputable. I have a lot of respect for the guy. He's done some amazing things. You guys will appreciate his background. And that's one thing that is kind of a new modus operandi is it's not for everybody, this type of coding. And, there's a lot to be made for not as much effort, if it's done incorrectly. And what I mean by that is it's very, very difficult to do correctly, but very easy to make it seem like you did it correct. So, we're very strict now, a lot stricter on our criteria for hiring now because of, some of the lessons that we've learned. And I've just learned that, one of the strategies was, I learned all that I learned, and I'll teach other people to think that same way. And, overall, they're going to, learn and become powerful developers themselves and stuff, but you can't really teach old dogs new tricks. So, I'm focused now on just finding very experienced, reputable people that get it, that are very technically proficient. And, that requires a higher hourly rate, at times, but we're happy to pay that just because quality is something that we can't sacrifice on. We can't, we can't sacrifice quality for availability of developers, right? So I'd rather do it myself than, have people that just don't fully get it, right? So these new people, Victor, as you saw, he's newly introduced. This new hire that I'm working on, hopefully he should be coming sometime in June, depending on how everything pans out with some other stuff. Sometime this summer is when I'd say that I'm expecting him. And then another developer who you guys have probably seen around, he's joining, I think in a week or two. He's pretty close to joining on the Wallet team, right? So we've been spending time, even at a reduced budget. We're still over budget, or under budget, I should say. We're still in the green. We're still running lean and mean, even when the price went way up. We weren't thinking about spending everything quickly. We were just keeping it very, very methodical and being very parsimonious. And like I said, focusing on hiring high quality people that understand the vision of Nexus, most importantly, and then also have technical proficiencies and an open enough attitude to be able to break out, potentially old destructive habits, right? But ultimately, our goal is to find people that we don't have to really, find people as good or better than me. That's our strategy. So this new developer that's going to be kind of working with me on the back end, I do believe is, at least at my level, if not better in certain areas. And he's got a lot of experience in financial technology and high scalability systems, which is cool. So I'm really excited about that. I'm really happy to be surrounded by great people. The last few months has been pretty intense as far as lots of opinions going around and lots of people, maybe seeing they're not as aligned, other people finding out they're even more aligned. But ultimately on the team, as far as the team environment, the team culture, the team morale, it's been much better than it's ever been before. Everybody's really becoming autonomous. There's also a mining working group now where we got three main people that are working on the mining working group. So they're actually building the US chain now. We have 2 FPGA, field programmable gate array miners, coming out. And we're also working on a hash pool, an open source hash pool that these FPGAs will plug into. So you'll be able to start buying field programmable gate arrays to mine the hash channel. And then obviously improving the prime sieving algorithms. I'm still always looking for new algorithms and new ways to improve that. So if anybody has any ideas or, has good experience with sieving, using wheel factorization or any other, segmented sieving or bucket sieving or whatever else, definitely, shoot me an email or just find me on Telegram. That's where I'm hanging out these days. Vidalicit as always, so you guys can find me there. We're offering bounties, as a part of the mining working group. Now these 2 FPGAs are moving along, and then, like I said, somebody working on the pool infrastructure for that. So we really, one of the big things that we decided to do with this upturn in the price uptick is that to invest time and money into improving the overall mining decentralization, right? Which has suffered quite substantially because of lack of funding, really, to really develop miners, right? That were technically proficient and competitive. So thankfully, we've got a lot of really cool people that are helping out on that. The mining working group is led by Jefe. So if anybody remembers, there's 5 main working groups on the developer. We have the LXOS working group, which Victor's kind of the chair of, and then the LLL Tau working group, which is the one that I mainly work on. And then we have the mobile wallet working group, and that's mainly Christo driving that. And then we have the wallet working group, the regular wallet working group, and that's mainly Kendall driving that. And then we have the mining working group, and that's mainly Andrew or Jefe that's working on that. And so it's kind of a democratic system. So they're all pretty much autonomous working groups. I mean, the mining working group, they just say, hey, this is our budget that we need, send the invoices, and I just pay the invoices, and then they ask me if they have questions and answer them. And that's pretty much the extent. Otherwise, they're just rocking and rolling themselves, which is great. That's what we want to see, seeing more internal democratic systems, and seeing the social organizational model coming to life, working well. And I had one more thing to add about Tritium++ to review. Tritium++, what this update I'm releasing now with is SQL language. In the API, it's a lot of Tritium++ code. It's the styles and the skills and everything I learned through 2020 that really became, a lot of the foundation of Tritium++, but that's in the API layer. Then the first phase of Tritium++, hard fork, is going to be, on the consensus layers, right? So that's going to include pooled staking, partial order fulfillment, and also forgot to add 5.2. The 5.1 is what I'm working on right now. 5.2 is going to include order indexing. So, as you see, you have this search functionality now. You'll also be able to index, as I'm adding API layer indexing, you'll be able to index markets, right? So as an NFT developer, you'll be able to basically create a token marketplace, and then you'll be able to search with your wire queries now any aspect of that, right? So those are coming before the first hard fork. So you'll be able to, basically have decentralized exchange, but it's only going to be swaps, which means it's a 1-for-1, right? You whole asset for the whole total that they're requesting. If it's a token swap, it has to be 1-for-1. There's no partial yet until the first phase of Tritium++ with that hard fork. That's when we're going to be adding the partial order fulfillment. So you'll basically have the functionality of a centralized exchange. The way I'm designing at least the marketing system is it should feel like a centralized exchange. And then when you execute the order, okay, the order goes into the memory pool and the memory state is automatically calculated with Nexus. With Ethereum, until the block is processed, you don't know what's happened, right? With Nexus, as soon as you create the transaction, the state exists. And so that's basically like seeing the order, confirmed. So you'll see the order instantly, basically. So it will feel like you're trading on a centralized exchange. That's at least the design goal, because decentralized exchanges are cool, but they just, nobody's really found them to be incredibly performant, right? Now that we have, this indexing and the memory management and all that stuff, then we can get those types of functionalities. I mean, the order will clear about a minute or two after it's placed, but that will prevent anyone else from trying to, double validate that. Only one of those will get through, right? The other one will be rejected from the memory pool, and so on and so forth. So that's what to look for. To review, the hard fork is going to contain pooled staking and the next hash script, and pooled staking and the next hash script, and one more, the partial order fulfillment, sorry, on the decentralized exchange. So a lot to look forward to. It's been a while since we've been doing these updates, so I hope to be bringing the guy that's going to be working with me onto the next Zoom and introducing him to the community more, the new hire. I'm glad we got to introduce Victor. He's a really great guy. He's, like I said, been helping every part of the way. I'm really grateful to be having his guidance, and I think that pretty much summarizes everything from this last crazy time. But let me see, how do I say this? Things, don't always think that positive is positive. Like, we've had some, you could say, setbacks, right? But I consider it dead branches. Sometimes you got to trim dead branches so everything else grows more bountifully, right? So, the last few months have been kind of trimming dead branches and cutting away stuff that's not working. And, that's where you get the negative energy. Negative is concave, right? Negative comes in. You're trimming, discerning, you're cutting away at it, right? So that comes in the form of negative energy. People go, right? But because of all of that, it ultimately clears the space so that there's more energy that can go towards the sustenance of the life that exists already. And that's really what I've been witnessing a lot with Nexus. And this query language right here is a great example of that. It's been birthed from all of this adversity and difficulty and all of that. And it's just a lot of beautiful things are coming out. The team sentiment and atmosphere, it's just, the IQ in the working groups is just skyrocketed. It's amazing. When I go in there, there's so many great people getting involved now and helping and contributing their perspectives, and it's really starting to grow an awesome snowball. Lots of artists are getting involved, and we're seeing, we're going to connect with the people. Okay, Ethereum, Cardano, whatever, they're going after the big mega corporations, but that's not the future. The future is the people, right? And the people really aren't in Bitcoin. Like, maybe they'll buy a little bit of Bitcoin and, think they're going to make some money. But, there's a lot of people that are like, I don't want to like do that. I'm not an investor. Like, I'm not going to use it. So the digital gold narrative's kind of like fallen away. Now we're focusing on relating to the people, right? The 7 billion people out there, 99% of everyone, right? And that's really what's going to change things. And, I think a lot of the larger cryptocurrency projects have lost that connection with the people. They're focused on catering to large corporations or catering to governments or the United Nations or whatever else. We're focused on reaching the people and connecting with the people on those fundamental levels, right? Through art and music and all these other really amazing things. We found some really amazing, how should I say, structures too, like legal structures and everything. So there's been so many awesome codes that have been cracking. So it's just know, like, that's our main focus. And when you're out there talking about Nexus and stuff, like, just remember, like, it's for the people, by the people, for the people, right? That's what we're here to build, because that's who needs it. These big mega corporations don't need this crap, man. They already have enough power and control as it is, right? It's the people that need this. And so that's who we're really focusing on relating to. And I'm seeing that happen more and more and more. And lots of new people are getting involved. And there's so many billions of people on the planet that are not into crypto. They know about it, but they're not into it because it's scary. You got to download a Bitcoin wallet and you could lose your keys. And, oh, it's an investment, or what is it? A currency, an investment? Like, what's Ethereum? It doesn't work. It's $5,000 to send a fee. What are you doing? Like, what's an NFT? How do I do it? How do I make it? I mean, I just had, the mother of my kids ask me, hey, you know about NFTs, man? I'm like, well, yeah, but it's like, how do I do it? I'm like, well, it's not like, you can't just be like, here, this is how you go do it. It just doesn't work that way, right? So there's a lot of interest in people. And like, I believe that the seed has been planted, right? The promise has been created, the promise of blockchain, the promise of the internet. And I don't think it's been fully fulfilled yet. And that's what we're here to do. And, it starts with little things like these query languages, and then the conditional contract language, and, getting the right people involved. But just remember that we're here for the people. We're here by the people, for the people. If you look, actually, I'll show you a little Easter egg, if anybody's noticed. Let me go. Every source code file has a little quote, right? Right now, it's all the same quote. You'll start finding new little quotes popping in if you decide to look at the source code. But the main motto of the Trading Protocol and Nexus in general is ad vocem populi, which means to the voice of the people. So on that, thank you everybody for being involved. Thank you for watching, and until next time.